I'm first going to expand these brackets to get sec squared x minus 2 lots of sec x tan x plus the integral of tan squared x. Now, we know sec squared integrates to be tan, so that's nice and easy. The sec x tan x, that is also on the formula sheet. That's going to integrate to be sec x. The one thing that isn't is tan squared. But that's okay, because we know that tan squared is equal to sec squared x minus 1. So we're actually going to have 2 sec squared x's to integrate, and the minus 1. All of these terms integrate easily now then. The sec squared will integrate to be tan. The sec x tan x is going to integrate just to be sec x. Look at the formula sheet for that one. And the minus 1 will integrate to be minus x. And there we go. I'm going to rewrite the cosec 2x as 1 over sine 2x. The cot, let me write that as cos over sine for now. Right, let's deal with this sine 2x, the sine double angle. I can turn that into 2 sine x cos x. And now I can see that this cos x here is going to cancel with this cos x here. And I'm going to be left with the integral of 1 over 2 sine x times sine x, so 2 sine squared x dx. Well, 1 over sine is cosec, so I could rewrite this as the integral of 1/2 cosec squared dx. Here's my 1/2, and the 1 over sine squared has become the cosec squared. And that's useful because we know what the integral of cosec squared is. It's on our formula sheet. Our formula sheet tells us that cot differentiates to be minus cosec squared. Therefore, cosec squared is going to integrate to be minus cot. Check that out on your formula sheet. So this is going to integrate to be minus 1/2 cot x plus c. The integral of cos to the power 4x. I can think of that as being cos squared x squared. That's the same thing as cos to the power 4. And that's going to be useful because cos squared, I know I can rewrite that with the cos double angle. So let's replace this with the cos double angle. I know cos 2x is equal to 2 cos squared x minus 1. Rearrange to make cos squared the subject. So I can replace that cos squared with a half cos 2x plus 1/2. Right, I can now expand those brackets again. So a half cos 2x times a half cos 2x is a quarter cos squared 2x. A half cos 2x times a half is a quarter, then double that, so we'll get a half cos 2x, and a half times a half is a quarter. Right, the quarter will integrate easily. This cos 2x will integrate relatively easily. This cos squared here will not. But we know how to deal with cos squared, remember? We've just done it just a moment ago. We've done it here. But I just need to adapt it a little bit. So let me take that same thing, bring it down. And let's compare. I need to divide both sides by 4 to get a quarter. And I also need to turn the inside here to be a 2x. So if I change this to be twice as big, that's going to change this to be twice as big, so that's going to be a 4x there now. So I'll get 1/8 cos 4x plus 1/8, and that's what I can now put in here. So I'll get the integral of 1/8 cos 4x plus 1/8 plus 1/2 cos 2x plus 1/4. These are like terms, so we can add them together. That's going to be 3/8. And after all of this hard work, we can now integrate each of these terms. The cos is going to integrate to be sine, but I do need to divide by 4 because of the reverse chain rule. So this 1/8 is going to turn into a 1/32. The 3/8 is going to integrate to be 3/8x. Cos is going to integrate to be sine, but I do need to divide by 2 because of the reverse chain rule. So this 1/2 is going to turn into a 1/4. Plus the c, and we're done.